Alrighty, you guys. So we are going to talk about domain and continuity with a function for today. Last time we looked just at the graph. So everything we looked at last time, we had a graph to refer to. Today, we're going to take away the graph and just look at, based on the function, can I state the domain? Can I determine if this function is continuous or not? So as a little warm-up, something that we've seen before, but not for a little while, I want you to find the y-intercept for each of those functions. Find the y-intercept for those functions. If it exists, find the y-intercept. What should you do to find the y-intercept? Plug in 0 for x. So find the y-intercept for me. So if I start plugging in 0 for x for my functions, for this first function, we would get -3. -3 squared is 9. 2 times 9 is 18. 18 plus 4 is 22. We have a y-intercept for that first function at 22. For our second function, if I plug in 0 for x, what do we get for our y-intercept? 1, right? 3 to the 0 power is 1, so we have a y-intercept at 1. And then for our final function here, I've got the square root of 0 minus 2. So we get the square root of -2. What does that tell us about a y-intercept? We're undefined at that point. We don't have a y-intercept. So what that means when we sort of talk about things like this in the context of domain is that 0 is in the domain of f and g because I can plug in 0 and get an output. But 0 is not in the domain of h, okay? Based on what we saw with our function there. When I plugged in 0, I got something that was not real, something that is not defined in the real numbers, okay? So when we talk about finding domain from a function, okay, what we're gonna keep in mind is, are there values that I could plug in for x that would result in something undefined? And remember, when we say undefined, we're usually talking about dividing by 0. Okay, so it would give me something undefined, or that would give me the square root of a negative number. Those are the things we're going to keep an eye on. Okay, so we're going to start by talking about polynomial functions. You guys have seen and worked with polynomial functions before. In Algebra 1, when you worked with linear functions and saw quadratic functions, those are all polynomials. We'll see more polynomials this year. We've already seen other polynomials this year. When we talk about polynomials, we're talking about any function that uses typically x as its variable and has some sort of positive integer exponent. So a linear function, y equals x, that would be x to the first. And we could have variations on this, right? I could have 2x maybe -4, that's also a linear function. Any variations on quadratic, cubic functions, quartic functions, x to the 5th power. Anytime I'm looking at positive integer exponents on my variable, that's a polynomial. So we're going to talk about all the polynomials together. Again, the thing that we want to keep an eye on is, are there any values of x that if I plug this into the function, gives me something divided by 0, right? Something undefined, or the square root of a negative. Now, the square root thing, we should be able to throw out right away, because do we see any square roots here? If I don't see any square roots, do I have to worry about taking the square root of a negative? No. Okay, so I don't need to worry about the square root thing here. So let's talk about undefined. Are there any values I could plug in for x on any of these functions where I would be dividing by 0? Well, one thing to look for is Is there division in any of these problems? Any of these functions? Am I dividing by anything? Do I see like 4 over x plus 2, anything like that on any of these? No. I mean, to be fair, we do have a 1/2 here and a 1/8 here. But is there anything I could plug in for x that would result in this 1/2 being undefined? No, because it doesn't have an x, right? It's 1/2. It's not got a variable. Same with our 1/8. It doesn't have a variable. It's 1/8, which is a constant, which is a value, a number. So the next thing that I want to consider and that I want you to think about anytime that we're talking about graphing later on or about domain now is the sort of big categories of numbers that we want to consider. So is it okay to use positive values? Is it okay to use negative values? Is it okay to use 0? And is it okay to use a rational number? So fractions or decimals. So if I look at my first function, can I plug in positive values for x? Sure can. Can I plug in negative values for x? Sure can. Can I plug in 0? Yep. Can I plug in fractions? Sure. Yeah. And we already said there's nothing I could plug in that would result in this function being undefined. There's nothing I could plug in that would result in this function having the square root of a negative. So are there any restrictions on my domain here? Are there any x values that do not work? No. So our domain here would be all real numbers from negative infinity to positive infinity. And I'm going to give you both of those notations today, just like last time. All real numbers is another way that we can say that. How about B? A was a quadratic, B is a linear function. We already talked about square roots of negatives and undefined, and none of those things apply here to B. Could I plug in positive values for x? Could I plug in negative values for x? Yeah. Could I plug in 0 for x? Sure. Could I plug in a fraction or a decimal for x? Sure. So what do we say about the domain on B? It's all real numbers. Everything from negative infinity to positive infinity is fair game. What about C? Are there any issues I'm going to have with x values for C? Anything that I cannot plug in there? Anything I cannot plug in for C? I can plug in positives, I can plug in negatives, I can plug in 0, I can plug in fractions, I can, like, there's no square roots of negatives aren't going to be a concern. I'm not going to have anything undefined. So this is, again, all real numbers. For any of the rest of our example problems, are there any issues that we need to be concerned with for the domain? No. Again, we talked about undefined values. That doesn't apply here. We talked about square roots of negatives. That doesn't apply here. I can plug in positive values for all of my remaining functions. I can plug in negative values for all of my remaining functions. We can plug in 0 for all of our functions. We can plug in rational numbers for all of our remaining functions. So all of these have a domain of negative infinity to positive infinity. I'll do the other notation on this one just to mix it up. They all have a domain of all real numbers, okay? There are no values for x that we can plug in that would result in something undefined or the square root of a negative, something non-real. I'm not going to have any issues here. In fact, all polynomials, not all functions, but all polynomials have a domain of all real numbers. So the domain of any polynomial is negative infinity to positive infinity. We're going to talk about exponential functions next. So an exponential function is when it's sort of like the opposite of a polynomial. For a polynomial, the base is a variable, the exponent is some positive integer. For exponential functions, the base is the number, right? Doesn't have to be an integer. We could look at rational number bases as well. But the base is the number and the exponent is the variable. So exponential functions would look like these. Notice you have a variable in the exponent. Even if there's other stuff in the exponent, that's okay. But you have a variable in the exponent. That's an exponential function. So let's talk about domain for these guys. So if I am plugging a value in for x, and x lives in the exponent, for any of these, do I need to be concerned about taking the square root of a negative number? Are there any square roots here? No, there's no square roots, right? So I don't need to be worried about that. Do I have division where I could potentially get something undefined? No, right? No division here. So we need to check the zeros, the positives, the negatives, all that good stuff. So if I look at A to start, 4 to the x, can I plug in 0 for x? Sure. What's anything to the 0 power? 1, right? That's fine. Could I plug in a positive number for x? Absolutely, we sure could. Could I plug in a negative number for x? Yeah, right? Negative exponents give me the reciprocal. So if I plugged in a negative value, that's fine. I would be looking at the 1 over 4 to some power, and that's okay. Could I plug in a fraction or a decimal? Sure, we talked about rational exponents, right? If I plugged in a half there, I would be asking you, what's the square root of 4? If I plugged in a third there, I would be asking you, what's the cube root of 4? And that may not have a nice like integer solution, but it's fine. It's a real number. Is there anything that I can plug in for x that would result in something non-real or undefined? No. So our domain for this guy is anything from negative infinity to positive infinity. How about B? Will I have any problems with B? Can I plug in positive numbers for x? Sure. Could I plug in negative numbers for x? Sure. Could I plug in 0? Sure. Could I plug in a fraction or a decimal? Sure. So our domain is all real numbers here again. How about C or D? What's our domain on C and D? All real numbers again, right? When I'm plugging in values for an exponent, anything's fair game. Any real number is fair game. So are there any values that we can plug in to an exponential function that would result in something non-real or undefined? No. So exponential functions, exponential, have a domain of, again, all real numbers. So anything from negative infinity to positive infinity. So we talked about polynomials. We talked about exponential functions. Let's talk about some square root functions next. So square root functions mean we have a variable under a square root, okay? Y equals the square root of 2 times x is not a square root function. This would be a linear function because the variable is not under the square root. This is a square root function, and this is a square root function, and this is a square root function because our variable is under the root. That's what makes a square root function, okay? So this is our sort of parent square root function, and then we can have all kinds of variations on our square root function. We've got square roots here, so do I need to be concerned about taking square roots of negatives? Yes, absolutely, yes, yes, yes. Do I need to be concerned about dividing by 0 on any of these? No, that's not a concern I need to have right now. but square roots of negatives is something I need to worry about, okay? So if I take a look at, let's actually take a look at our parent function right here. Can I plug in positive numbers for x? Positives are good. Can I plug in negative numbers for x? No. Could I plug in 0? Yes, we can take the square root of 0. 0 is okay. Could I plug in a fraction or a rational number as long as it's positive? Yes. Now, are we always going to get a nice value out of a square root function? No, that's okay. Domain doesn't mean just the nice, pretty x or x values that we can plug in. It means all the x's that we could possibly plug in, and the output, the range, would be all the y's we could possibly get. Okay. So with that idea, 0 is okay. Anything bigger than 0 is okay. Absolutely no negatives. Let's take a look at A. Could I plug in positive values for A? Any positive number? Sure. Could I plug in 0? Yes. If I plug in 0, I would be taking the square root of 3. That's okay. It's not a nice number, but that's okay. Could I plug in fractions? Yes. Positive fractions for sure. Could I plug in negative numbers for x? I've got some waffling on that one, negative numbers. Are there any negative numbers that I could plug in for x? Could I plug in any negative number? No, that's the difference, right? I can plug in negative numbers up to -3. Can I include -3 in the domain? Yes, -3 would be okay. If I plug in -3, I would get the square root of 0, and the square root of 0 is 0. That's okay. Anything bigger than -3, -3.1, nope. -3.0000002, nope. Okay, then I would be taking the square root of a negative number. So my domain here would be all values of x that are greater than -3. If you're using interval notation, you want a bracket on -3, and then infinity is always a parenthesis. I could also write this as x is greater than or equal to -3 for our domain here. How about B? Could I plug in positive values for x? Yep. Could I plug in 0 for x? Sure thing. Could I plug in negative values? Absolutely not. No negatives allowed. Could I plug in as long as they're positive rational numbers? Sure. So our domain here would be values 0 or greater, right? X has to be greater than or equal to 0. So in interval notation, we get a bracket at 0 because we can include 0. And then as an inequality, x is greater than or equal to 0. You could, if you wanted to, also write this as 0 is less than or equal to x is less than infinity. How about C? 1. What happens at 1? Is 1 included, excluded? Included? Bigger than 1? Okay. Smaller than 1? Not so much. 1 is that sort of tipping point, right? So we're going to include 1 and any value greater than 1. What about D? This one's kind of the opposite, right? Since we're subtracting x, negative numbers are okay. Could I include any positive number? Up to 3, right? 3 is the maximum. So this time, we actually can include any negative number that we would like, and then positives, but only up to 3. So this would be x is less than or equal to 3, or negative infinity is less than x is less than or equal to 3. So were there values here that we had to exclude because they gave us a non-real value? Yes. Can I make a general statement about the domain of all square root functions? Like all real numbers like we did for No, I can't say all positives or all negatives, or that's going to depend on the particular function, right? For square root functions. What we can say is that we need x values that results in 0 or positive numbers under the square root. So if it's a square root, I have to be taking the square root of minimum 0 or anything positive. 0 or anything positive under the root. Keep in mind that we talked specifically about square roots here, not about cube roots. Okay, cube roots are kind of their own thing, because it would be okay to take the cube root of a negative, but for square roots or any even root, I would need to have 0 or a positive number under the root. And now let's talk about logs. Okay, we saw logs in our last unit. We're going to see them again here. Logs related to exponential functions, right? They're the inverse of our exponential functions. They look like this. We can have a lot of stuff going on in the argument. We can have numbers that we're adding or subtracting after the argument. That's fine. But we're looking at something where our variable is in the argument of our log. Variable in the argument of our log. Because they're the inverse of exponential functions, and an exponential function has its variable in the exponent, that means our log needs to have its variable. To talk about it as a log function, needs to have its variable in the argument. Okay. Sometimes it is helpful, remember, to rewrite logs in that exponential format as we are talking about maybe what would be values included in the domain or not. Okay. So if we take a look at our first function, log base 2 of x, I'm going to rewrite this as an exponential, at least on this first one, just so we can talk about the kind of values that is okay for x to be. Okay, because remember, it's got that tie to exponential function. Now, if we were talking about what can I have for y, anything goes. That's fair game, right? But we're talking about what's going to be sort of the end result of taking something to a power, right? The inverse of our exponential function. I'm not asking what can I plug in for the exponent. I'm asking what kind of things can I get out here. So are there any things that I cannot get from doing a power of 2? There are 2 types of numbers that won't work. So let's run through our list, see if we can find them. Could I get a positive number here? Could I do 2 to something and a positive number? Sure can. Can I do 2 to some power and get a fraction, potentially? Sure. If I used a negative exponent, we could get like a 1/2 or a 1/4, right? Could I get 0? Could I do 2 to some power and get 0? That's a no. Could I do 2 to some power and get -2? That's also a no. So 0 is not part of our domain. Negative numbers, not part of our domain. We can go close to 0, but not 0. So I'm going to use a parenthesis there. We can use fractions less than 1. That's fine. As long as they're not negative, as long as they're positive. And then anything positive is fine, but not 0, nothing negative. For B, same idea. This would be 5 to the y equals x minus 2. Now, what I want you to keep in mind is it's not just x. This time it's x minus 2. So what we need to be careful of is that this whole part, the argument, can't be 0 or negative. So where's that boundary? it would be at 2, right? But it can't be 2. Very good. If I plug in 2, that makes the argument 0, and we can't have the argument be 0. If I plug in anything less than 2, that would make my argument negative, and I can't have that. So it's got to be something greater than 2. Okay, or 2, like that, or x is greater than 2 would also work. What about C? Our argument is x plus 4 this time. What do you think about the domain on that one? Mm-hmm.
It has to be greater than -4.
X has to be greater than -4. If we plug in -4, that would make this 0. That's not okay. If I plug in -3, this would be 1. That's positive. That's okay. Any bigger value, any positive number is okay. 0 is okay here because then the argument would be 4, but nothing less than 4. X has to be greater than 4. And then how about D? What's our domain on D? Mm-hmm. X has to be greater than 0. The only thing in our argument there is x, so x has to be greater than 0. So 0 to infinity, not including 0. So are there x values that could make the domain of a log undefined? Yes. Can I come up with a one statement that applies to all logs? Like the domain of all logs is 0 to infinity? No, right? Because we saw places where 0 cannot be included in the domain. Actually, saw lots of places where 0 cannot be included in the domain. We saw places where 0 can be included in the domain. So we're looking for x values that result in the argument of the log being greater than 0. So we talked about 4 different types of functions today. So the domains of 4 different types of functions. Polynomials, exponentials, square root functions, and log functions. The next type of function that we'll talk about next time is called rational functions. So again, we'll continue to look at, are there x values that are not okay to plug in? What can I have in the domain? What can I not have in the domain? Your homework is page 10.